Hello everyone, welcome to our channel OnlyPhysics JEE Grad. So in this video, we'll be discussing JEE Advanced PYQs from the chapter Thermal Properties of Matter. This will be the first video from this chapter, and the topic we'll be discussing are heat and thermal expansion. The part will be based on thermal expansion. Okay, so there will be 13 questions we'll be discussing. Let's start with our video. And one more thing. All the JEE Advanced PYQs, which are topic wise and chapter wise, will be arranged properly in the playlist on our channel. So do check it out. So let's start with our video. This will be our first question. Right. So in this question, an external pressure P is applied on the cube at 0 degrees Celsius so that it is equally compressed from all sides. Okay, perfect. The K is the bulk modulus of material of the cube and alpha is its coefficient of linear expansion. Right. So if it is equally compressed from all sides, right? So we can take gamma will be 3 alpha, right? So we'll be considering that the expansion will be equal in all the direction. Suppose we want to bring the cube to equilibrium by heating, the temperature should be. So what is happening is we have a cube. This is at 0 degrees Celsius and we applied a pressure, right? This pressure won't affect its shape, but what will happen when I start to heat it up at T degrees Celsius, what will happen? It starts to expand. Then internal pressure will be up there. So what will happen is at this T degrees Celsius, P internal will be equal to P external due to expansion, and hence stress will be created. Stress will be created, right? So using this concept, we have to find the temperature at which this is happening. So let's start. We have bulk modulus. So bulk modulus is given as K will be equals to stress, or we can say pressure. It must be pressure here. Okay. So it's pressure divided by delta V by V. So K is what in the question we have given. It's bulk modulus, right? So let's just start to find. So let's first write what is this. So let's cross multiply it. So del V by V equals to pressure, which is P. Now we know del V by V is gamma delta T, and delta T is what? T minus 0. So it will be simply T and gamma will be 3 alpha into T, right? So let's just put it here. We will get K 3 alpha T is equals to P, and we have to find T. So T will be P upon 3 alpha and K. So this will be our answer, right? So we have it. It's an easy question, of course. Let's move on to the second question. Perfect. Now, there is a wooden wheel of radius r made up of two semicircular parts. So this is a part 1. So this is part 1. This is part 2. Okay. Are held together by a ring made of metal of cross-sectional area S. So this is our strip, right? And this is our wheel, right? Are you getting me? And this shaded area is actually S, right? So you know this concept of applying metal strip on the wheel. First, we expand this metal wheel by heating up because the length of this strip is generally less than 2 pi r initially. So we heat up so that it expand. As it expand, we apply this strip on the wheel and then we'll cool it down. So then we cool it down. So due to this, the length will decrease, right? length will decrease and it will perfectly fit our wheel, and it will clamp these like semi-circular wheels. Okay, so this is the concept we will be using. So look, here it is given L is slightly less than 2 pi r. Okay, to fit the ring, it is heated so that its temperature rises and it just steps over the wheel because it expands, right? So as cool down, it will cool down, it will shrink, and due to this shrinkage, it will perfectly fit the wheel. It presses the semicircular parts together. Okay, perfect. But the coefficient of linear expansion is alpha. So the change in areas we do not have to take because Young's modulus is given. So what is Young's modulus? It's stress upon strain, right? The force that one part of the wheel applies on the other part. So we have to find this force. So let's first find the stress. So what will we have? What we'll get? Stress will be equal to y into strain. Y into strain. Yes. So Young's modulus is given and strain will be delta L by L, right? Delta L by L. Now delta L, how to find this? So we'll use the coefficient of linear expansion. So we'll get delta L by L will be equals to alpha delta T for delta T. So we'll just write Y alpha delta T will be our stress. Okay. So stress is like a pressure, which is force per unit of area. Now look, this stress will be available or will be equally distributed to all part of the surfaces, right? So look, this strip is applying force on this wheel, right? So let me make the wheel here. So let's say this is our wheel, okay, right? So in this we have a pressure. Now look, this wheel is in contact with this part of the wheel, right? Is in contact with this part of the wheel. So if pressure is applying here, so this part of the wheel will be applying a pressure here and as well as here, right? Right? So look, this strip will be applying a pressure here, and this part will be applying pressure here. This will be applying pressure here. So as Newton's third law, every action has equal and opposite reaction. So on this part, the same pressure will be here, and the same pressure will be here. Okay. Now, of course, this is like P is applying here, P and P above. We have to consider it as a force. What is happening? What is happening is on this part, there is this force which is in the downward direction, right? And this we have, we will consider it as F1 and we will consider it as F2. Okay. Now, let's try to find out how this will uh, how it will be changing. Okay, right. So look, uh, if this strip is pulling or it's compressing this wheel, right? So what is happening is this strip is applying some tension. So if I find this tension, if I find this tension will be the area will be the S. So on, in the whole strip, the tension will be this, right? In the whole strip, the tension will be this. Okay. Now, uh, as by symmetry, we can write this as F and we can write this as F, and let's say this is F dash. Okay. So look, what is happening is what is happening is the tension will be in the whole strip, and due to this, the tension will be same in the whole wheel, right? So actually, this part applying this force, it is actually nothing but it is the tension itself, right? Similarly, this is nothing but it is the tension itself. Okay, so this part applying F. So let me write it as T. Okay, let me write it as T. So let's say this is T and this is also T. Okay, now So how much tension this part and this part applies on this wheel? It is actually 2T. So F force required will be 2T. So it will be 2 times of Y alpha delta T S. Okay, Y alpha delta T S. So it will be C option. Okay, so it's a quite interesting the concept here. So we'll have like pressure, the concept of pressure, Young's modulus, and the concept of tension. So it's considered, I will consider it as a moderate one. Okay. Next, let's move on to the third question. Let's move on to our third question. Right. So we have this. Now here we'll be using the expansion part, thermal expansion, and the ideal gas. Okay. So we have given Pt square is some constant K, right? And if it is ideal gas, we will write PV equals to nRT, right? The coefficient of volume expansion. So we have to find delta V by V is what? Gamma delta T, right? And delta T will be what? The coefficient of, okay, so we'll check this. Right. So what we'll do with this here, the volume expansion, coefficient of volume expansion means this gamma we have to find. So we'll know, we should know delta, what is delta V by V, right? Okay, so what can we do? Look, we see there is no pressure here. So if I divide these two, what we'll get? So it will be V by T square. It will be NR by K. K is some constant, right? So this is some constant. And into T, right? Into T. So we will be nRT cube by K. So this is another constant. So we'll write simply V is equals to C T cube, right? Now if I partial differentiate it, we'll get delta V by V will be equal to 3 delta T by T, right? Unit and dimensions, okay? So let's put delta V by V here. We'll get 3 delta T by T. So from this and from this, we'll get 3 delta T by T. 3 delta T by T will be equals to gamma delta T, right? Delta T will cancel. So we'll have gamma will be equals to 3 by 80. So this is quite interesting. C option will be there, right? So it's an easy, but it is quite interesting. You have to think like this. Perfect. Let's move on to our fourth question. Let's move on to our fourth question. Okay, what we have here is a metal ball immersed in alcohol weighs W1 at 0 degrees Celsius and W2 at 50 degrees Celsius. Perfect. The coefficient of cubical expansion of metal is less than alcohol. So what is happening is it may be possible that, yeah, it is possible if it is given that they have both have coefficient of cubical expansion. Both metal and alcohol are expanding actually, right? Assuming the density of metal is large compared to density of alcohol. So what is given is cubical expansion. So we write gamma of metal is actually less than gamma of alcohol. Okay, and also density of metal is large than density of alcohol. Okay, so your metal body is immersed in alcohol weighs W1. So what is happening if this is our metal ball? So look, there will be some buoyancy, right? There will be some buoyancy, buoyant force, right? Okay, and now, so what? whatever may be the its original weight, we'll say it's W naught. So the weight it will actually will be it will be W naught minus this band force. Okay, so we say this initial temperature is 0 degrees Celsius, and finally the band force will be different. So it's say, let's say it's B1, let's say it's B2, and this will be W naught. So for T1 at 0 degrees Celsius, the weight will be W naught minus B1, and for the second, which will be temperature will be 50 degrees Celsius, we'll have W2 as W naught minus B2. Okay, now we have to compare if they are equal, they less, more. Let's solve them. So we have W1 is equals to W naught minus band C will be rho 1 rho of liquid, okay, 1 V1, and this will be T. So this will be G, right? So density of liquid, volume of object submerged into G, right? Similarly, W2 will be W naught minus liquid to V2 into G. Okay. Now let's say at T equal to 0 degrees Celsius, the density of liquid is rho naught, volume of object is V naught. So this V1 is volume of object. As it is completely submerged, so we'll take this. And this is density of liquid, which is alcohol in our case. Now, at T degrees Celsius, at T degrees Celsius, what will be happening is the density of liquid will be rho naught upon 1 plus gamma into delta T, which will be equal to rho naught 1 plus gamma. Rho naught is at 0 degrees Celsius, so delta T will be simply T. Similarly, V2 will be, okay, so this is, so V2 will be V naught 1 plus, okay, so we have taken different, so this is gamma of liquid and this is gamma of metal, right, into T, because V naught is the volume of object at 0 degrees Celsius, so V2 will be gamma T into T minus 0, so it will be simply T, right? So we have these situations. So if I put them here, we will get, so W2 will get W naught minus, so it will be rho naught V naught G, it will be 1 plus alpha gamma L T upon 1 plus gamma M T, right? And this is clearly what? So this was, so if I write W1 as W naught minus rho naught V naught into G, right? So let's just compare. If this value is greater than 1, this value is greater than 1, then W2 will be less than W1 because it is subtracting from this, right? And if this value is less than 1, so we will have W2 will be greater than W. So because it is subtracting, so W2 will be okay. Now, clearly, we just have to compare gamma L and gamma M, right? So we have in the question it is given gamma of M is less than gamma of alcohol, which is liquid, right? Right. So we have given gamma of metal is less than gamma of liquid, which is our alcohol, which is our alcohol. So if gamma metal is less, right? Right? So there is some, okay, so liquid will go here. Liquid will go here, metal will go here, right? Because liquid indeed. Perfect. Now, if gamma of liquid is more, then denominator is more. So overall, this value is less than 1. So if this value is less than 1, then from omega naught, the less value is subtracting. So omega 2 must be more. So this will be answer. So omega 2 will be more than omega 1. So which option is correct? Oh, omega 2 is more. So C option, right? So it's a pretty good question. I'll consider it as a moderate. Okay. Now there is a similar question like fourth. Okay. So we will first discuss that as our fifth question. So it's like, let me put this question for you guys. So it's okay. So this must be a question. No, this is not the question here. Okay, just wait. Right. So this is our question. Right. Perfect. So let me delete this. Now, in this question is exact same as the above, but here the calculation is very typical. So let's say, look, the same question, sinker. Sinker means object which is sinking in the liquid. Has a actual weight omega naught. Apparent weight is W1 at a temperature T1 and W2 at a temperature T2, right? The coefficient of cubical expansion of material is beta, right? So it's given the like gamma of metal is actually beta here, right? So we have to find gamma of liquid. Okay, so let's just write these equations again. So we have W1 was W naught minus rho naught V naught into G. This is at temperature T1. Okay, now the W2 was W naught minus rho naught V naught G into it's 1 plus gamma of metal. So metal into T. Now the T was our in the before question it was T minus 0. So here T will be T2 minus T1. So it will be T2 minus T1. So let me write it as delta T. Okay. So it's a delta T. Right? Divided by 1 plus gamma of liquid which we have to find to delta T. Okay. So look, we have to find this gamma L and we do not need this rho naught V naught into G. So we'll write, let's bring these two here and this one here. So we will have, let's update this equation. It will be rho naught V naught G is equals to W naught minus W1, and here will be rho naught V naught G into 1 plus gamma M delta T or 1 plus gamma L delta T is equals to W naught minus W2. So let's just divide these two. So these will get cancelled. We'll have 1 plus gamma L delta T upon 1 plus. Now gamma of M is beta. So beta delta T, right? It will be equal to omega naught minus omega 1 upon omega naught minus omega 2. Okay. So the calculation will be a big headache here. Okay. So this cross multiply will be having 1 plus gamma L delta T equal to omega naught W naught minus W2 upon W naught minus W2 minus okay, multiply. So it's 1 plus beta delta T. Now this minus will come. So gamma L delta T will be equals to W naught minus W1 upon W naught minus W2 1 plus beta delta T minus 1. Okay. So let's cross multiply it here. We'll be having W naught minus W1. We'll just taking LCM 1 plus beta delta T minus W naught minus W2 divided by W naught minus W. Okay. So let's solve them. will having W naught minus W1, okay, plus beta delta T W naught minus W1 beta delta T minus W naught plus W2 divided by W naught minus W2. So W naught will get cancelled and we'll rearrange them here. Okay, we will be having gamma of L delta T will be equal to, so let's just take these two common, okay, and we'll left with W2 minus W1. So we'll have W2 minus W1 plus beta delta T W naught minus W1 divided by W naught minus W2, W2, right? So if I like rearrange them, we'll have gamma L will be equal to 1 upon delta T W2 minus W1 upon W naught minus W2 plus delta T will cancel. So beta into W naught minus W1 upon W naught minus W2. So it's a pretty big calculation. This will be our answer. Yes. So it's a similar question. Now let's move on to our sixth question. Right. So it's a question based on bimetallic strip. Okay, it's formed out of two identical strips. One is of copper, another is of brass. So we have one strip and we have another strip. So the length will be same. Okay. Generally, bimetallic strip are made like this. The length will be the same. The coefficient of linear expansion of copper. Let's say this is copper is alpha C and this is brass. This is P. Okay. On heating the temperature, the strip goes up by temperature delta T. So delta T is the temperature change, and the strip bend to form an arc of radius curvature R. So we have to find what is R proportional to. So this is a simple case which you must have studied with the formula. Let's just derive it again. So if it is bent like this, right? And why it will bend like this? Because the change in length will be different. So maybe the copper one will be bent. The change in length in copper is delta L, let's suppose delta L1, and it is say delta L2. So maybe it may be possible delta L1 is more than delta L2. I don't know which one expand more. So if this is the case, so it will bend like this, and if other one the case, it will bend like this. So it depends on the alpha C and alpha P. Okay, right. So if they are making an angle theta here, and this length is suppose L2 and this length is L, right? And this is our radius from here to here, right? And this is thickness D. Okay, so let's solve this. So we know theta equal to arc length by R, right? So for L1, we'll write theta is L1 divided by R simply. And for other, theta will be L2 divided by R plus D. So the D will be the thickness of both the strip. Okay. So if they are equal, we'll write simply L1 by R equals to L2 by R plus D. Now L1 will be L1 will be L naught 1 plus alpha of brass delta T, and L2 will be the initial length was same, L naught plus alpha of copper delta T. Let's just put these values here. Now we have to find the R. So simply let's do like this: R plus T by R is equals to L2 by L1, right? We will have 1 plus T by R is equals to L2 minus L1. So we will have d by r as L2 minus L1 by L1. So if I reciprocal both the sides, we will get R is equals to D L2 minus L1 by L1. Okay, sorry. I have to reciprocal them. So we will be having R by D is equals to L1 upon L2 minus L1. So we will have D L1 upon L2 minus L1, right? So R will be like this. Now let's put these values here. So we'll be getting D L1 is L naught 1 plus alpha B delta T upon L2 minus L1, right? L2 minus L1, if you subtract it, L naught will get cancelled, so it will be L naught alpha C delta T. So it will be simply this alpha C minus alpha B delta T, right? L naught will get cancelled. So we will have R will be D 1 plus alpha B delta T upon alpha C minus alpha B into delta T, right? So we will have like this. Perfect. Now, we could have taken some approximation here. So the situation will be slightly different, okay, if we have taken some approximation. So in this question, it is directly asking the proportional to delta t, inversely proportional to delta t, proportional to alpha beta. So we have to directly find the proportionality. So this is actually the exact answer, right? So we have to find it in the proportional way, right? So look, from here we can do some things. Let's put it from here. So it will be 1 plus, I'm finding just the second method. So it's a second way with approximation. Okay, let's so it will be 1 plus t by r. L2 will be L naught 1 plus alpha b delta t upon L naught 1 plus alpha c delta t. Now let's say, as you know, alpha b and alpha c will be very small, so we can simply write it as 1 by d by r. L naught will cancel, so it will be 1 plus alpha b delta t into 1 minus alpha c delta t, right? We can write this. So we'll have 1 plus t by r is equals to 1 plus alpha b delta t minus alpha c delta t. We will have minus alpha b alpha c delta t whole square. Now, as alpha b and alpha c is small, right? As alpha b and alpha c is small, so alpha b into alpha c be when less 0. So we can ignore this, so we'll make it as 0. So we'll have 1 will get cancelled. So we have d by r equal to alpha b minus alpha c into delta t. So we simply get so we'll simply get r as d upon alpha b minus alpha c into delta t. Okay. So this is an actual formula. This is our actual formula, right? And this is formula after approximation, right? So in this question, they want you to solve it by approximation. So we'll simply get r is inversely proportional to alpha b minus alpha c and inversely proportional to delta t. So we will have inversely proportional to delta c and inversely proportional to mod. Why they are taking mod? Because we don't know alpha b is more or alpha c is more, so they just have taken mod. Okay, perfect. So this is again a moderate question, right? Let's move on to the next question, shall we? So it will be question number 7, right? It will be question number 7. Okay, perfect. So question number 7, right? So this is a simple question. I can see, right? So we have two rods of different material whose coefficient of thermal expansion is this. Young's modulus is also given. Two rigid walls. The rods are heated such that they undergo the same increase in temperature. Okay. There is no bending of the rod alpha 1 and alpha 1. Okay, so this is very easy. So for first we'll write gamma 1 equal to stress upon strain, right? So this is what. And for gamma 2 we'll write stress 2 and strain 2, right? So simply now we'll write stress 1. I'll just write it as stress 1 will be equal to gamma 1 into strain 1. So delta L1 by L1. And for S2 we can write this is stress. Okay, so it will be gamma 2 into strain will be delta L2 by L2. Now we know delta L by L is alpha delta T. So let's just put them. So we will have, and the stresses are equal. So in question given S1 is equal to S2, so we will be right gamma 1 alpha 1 delta T equal to gamma 2 alpha 2 delta T. The temperature difference in both of them will be same. So gamma 1 will be simply gamma 1 by gamma 2 will be simply alpha 2 by alpha 1. And alpha 2 by alpha 1 is actually alpha 1 by alpha 2 is 2 by 3. So alpha 2 by alpha 1 will be 3. So this will be our answer. So C will be the option. So it's an easy question. Nothing to worry here, right? Let's move on to our eighth question. Perfect. So we have a cubical block of coefficient of linear expansion as alpha S. Okay, alpha S submerged partially in the liquid of coefficient of volume expansion gamma L. On increasing the temperature delta T, the height of the cube inside the liquid remains unchanged. Okay, so there is no effect on H, so effect will be on area, right? So look, the situation is like this. So we have a cube here, okay, and it is submerged in liquid like this by some H. So this area is changing. So this area is actually changing, and the height remains same. So it does not change, right? Perfect. So this is an important information. Now the find the relation between gamma alpha S and gamma of the liquid. Okay, perfect. So much partial liquid over coefficient. Right. So how will solve it? How will solve it? So we'll just use the concept of a buoyancy and weight, right? We'll just solve that. Now, look, if we'll say this h is the height inside the liquid, if we'll say this h inside the liquid, the object which is inside the liquid is h, right? It is same. So look, initially, let's say there is buoyancy B naught. and weight is W, right? Finally, finally, let's say it is buoyancy is W, but weight of the object is still W. This height is not changing, right? Right. So we'll say the initial buoyancy must be equal to final buoyancy. Are you getting me? Because the weight is not changing. Weight of the object is same, right? Weight of the object is same. Weight is what? Weight of the object is what? Mass into G. So even the object is expanding. The mass does not change. G does not change. So we will do same. So we'll write initial buoyancy. So initial buoyancy is what? Initial buoyancy will be rho naught. So we'll just write the liquid. Okay. So it will be rho naught, rho of liquid, volume of object inside into G will be equals to final. So density, how the change in density happens? It will be rho L naught divided by 1 plus gamma of liquid delta T, right? Volume of object is changing. How? So area is only changing. So we have to write volume as area into H, right? So this will be A naught 1 plus 1 plus, and we have given the linear expansion of F. So area for areal expansion, it will 2 alpha into delta T to H, right? So we write simply A naught 1 plus 2 alpha of solid delta T into H to G. So G will cancel, and we know V naught is what? So V naught is actually A naught into H. So V naught will get cancelled because the change in height is not there, only the area is changing. Huh? And rho naught L will get cancelled. So clearly we'll have this will go here. We'll have 1 by gamma L delta T will be equal to 1 plus twice of alpha S delta T. 1 will get cancelled, delta T cancel. So simply we'll have gamma of liquid will be equal to twice of alpha S. This will be our answer, right? So it is a simple question, again, easy question, but the concepts are many. Like buoyancy we have to use, right? And then we have to apply. So it's an easy question, nothing to worry. Let's move on to our ninth question. Perfect. So we have our ninth question here. Now, in this question, is given a small spherical body of radius r is falling under the gravity in a viscous medium. Perfect. Due to friction, the medium gets heated. How does the rate of heating depends on radius of the body when it attains a terminal velocity? Okay, so if it is heating, so there must be viscous force, and downward will be mg, and it is falling with a terminal velocity. Right. Now the radius of this is r. Okay. Now due to friction, the mediums get heated. How does the rate of heating depends on the radius of the body when it attains the terminal velocity. So the rate of heating, so it will be dq by dt. So we have to find dq by dt in terms of r, the radius of the body, right? Now we know dq by dt is what? Power. Okay. So power is what? F dot v. F dot v. Now look, the mg is pulling it downward, but the heating is happened due to this viscous force. So we have to write the viscous force. So it will be Fv into v vector, right? And of course it will come out to be negative because it is going downward and it is going upward. So the power is negative. It means it is taking energy, it is heating up the liquid, right? So Fv will be, we know the force of viscous, the formula is 6 pi eta r v, and this is v, so it will be v square, right? Now we have to find v in terms of r. So we know the formula of terminal velocity was 2 by 9, right? The complicated one, sigma minus rho, right? R square g divided by eta. So we'll just write it. So this power was dq by dt. Of course, it is negative, so I'm not putting. Let's put negative here. So dq by dt will be minus 6 pi eta r, and vt will be 2 by 9 sigma minus rho r square g by eta to the whole square. So it will be simply, everything is constant. I'm just writing minus. So I'm just writing it as dq by dt proportional to r4 and 5. So yes, so rate of heating is proportional to radius to the power 5. So if you take 1 meter of radius, the rate will be something, say k. But if you make it twice, the rate will be simply 32 times. Okay, this will be our answer. So again, it's an easy question, but you know this formula, if you don't remember, there will be problem. Let's move on to our 10th question. Right. So we have this. So this apparatus is shown in the figure consists of 4 columns like this. The height of B and C are 49 centimeter each. So this is 49. Okay. The two other columns A and D are open to atmosphere. A and C maintain at 95 while B and D 5. Okay, perfect. The height of A. So this is 52.8 and D is 51. So this is less. Okay. Determine the coefficient of thermal expansion of the liquid. So look, one thing you must know that we have to find the coefficient of thermal expansion. It is gamma or it is alpha. So it will be alpha. Why? The area is not changing. So it will only expand linearly. So we have to find alpha, alpha of liquid, right? Okay. So let's use the concept of pressure. In the horizontal surface, pressure will be same because this is a completely stationary. So let's say this is P naught. This is also P naught. So here the pressure will be P naught plus rho of liquid G, and look, this liquid is at temperature 95. So let me write it as 95 G into H, which is 52.8. I'm taking everything in centimeters, so it will eventually get cancelled. Now the pressure here and here will be same, so it will be the same. Now above, if you go down, the pressure adds up, but if you go above, the pressure decreases. So we'll write minus rho of liquid at 5 degrees Celsius. Okay, so this is 5 G into 49. So this is the pressure here, right? So we'll write pressure, this point we'll write at x. So pressure at x is this. Similarly, let's solve for this. So here is P naught. So here it will be, so here it will be P naught plus rho of liquid at 5 G into 51, and the pressure will be same. And if you go above, it will decrease, but this is at 95, so it will be minus rho of liquid at 95 G into 49. This is pressure at 5. So we'll write it as pressure at 5, right? Let me write it. P. Now, as the liquid in stationary, so Px must be equal to Py, right? So we'll just equate them. So P naught will get cancelled, and we'll equate the 5 degree. So we'll just write it low of liquid at 95, G 52.8. So calculation will be there, of course. G 49 equals to rho of liquid at 5, G 51 minus rho of liquid 95, G 49. So G will get cancelled out. 95, this part will go here. Sorry, they will add up simply. Rho of 95, 52.8 plus 49. How much it will be? So it will be zero point 0.8 and 1 and 1. So 101.8, right? Of liquid into of at 5 degrees Celsius. So 51 plus it will be simply 100, right? Okay, perfect. So we will have what we have to find the okay. So this is what rho of liquid at 95 divided by rho of liquid at 5 is what? 100 divided by 101.8. So temperature increases, density will definitely decrease. So let's write the formula. So rho of liquid at 95 will be rho of liquid at 5 divided by 1 plus gamma delta T, right? Gamma delta T, but we do not need to find the gamma. So gamma will be 3 alpha. So we'll just write this 3 alpha. This is in divide. So we'll be having rho of liquid 95 degree temperature divided by rho of liquid at 5 degrees will be equal to 1 upon 1 plus 3 alpha delta T. And delta T is what? Delta T is 90 degree. 95 minus 1. And this term is what? It is 100 divided by 101.8. So we'll just cross multiply. We'll have 100 plus, so it will be 27 and 30 to 27,000 alpha will be equal to 101.8. We have just done cross multiplication, nothing else. So alpha will be 1.8 divided by 27,000, right? So if I use calculator, so it will be 1.8 divided by 27,000 will get 6.67 into 10 raised to power minus 5, right? So this will be our answer. Of course, unit will be per degree Celsius. So write it as degree Celsius inverse. Okay. So pretty nice question, of course. So again, we'll consider it as moderate. Okay. Let's move on to our 11th question. So we have our 11th question. Perfect. So we have a thin rod of negligible mass and area of cross section as this. Okay. Negligible mass is negligible. So we have this rod suspended vertically from one end. So it is suspended. The mass of this is negligible. Okay. It has length. So we have length 0.5 at 100 degrees Celsius and area is 4 into 10 raised to power minus 6 meter square. The rod is cooled to, so if it is cooled, the length will contract the mass from contracting but prevented by attaching a mass. Okay, so we have attached a mass here, so it will not contract. Right? So find the mass, the energy. So it's a simple question. So we'll use Young's modulus. Okay, so it is saying the so we have linear expansion and Young's modulus is given. So they are considering there is no change in area. So it will be stress upon strain. So we have stress is force per unit area Y into strain. Strain will be delta L upon L. All right. So delta L upon L. So we'll just put the value. So we'll know delta L upon L is what? Alpha delta T. And alpha is we have, and delta T will be 100. So just to put the values, F upon 4 into 10 raised to power minus 6. Y is 10 raised to power 11. And delta L value is alpha into 100. So alpha is 10 raised to power minus 5 into 100. Okay. So we have simply F is 4 into 10 raised to power minus 6 into 10 raised to power 11 into 10 raised to power minus 5 into 100. Okay, so we'll just cancel them. So force will be acting 100 and this force will be balanced by mg. So g will get cancelled. So we have m as 40 kg. Easy, right? Now energy we can find. So we know energy density, the formula for energy density. Energy per unit volume is half stress into strain, right? So we will just multiply it by the volume, half stress. Stress will be force upon area. So it's simply, uh, we can just write this, yes. So we can write as gamma into strain, so y into strain square. So y into strain square into volume. So we'll have y is 10 to the power 11 and strain. Strain is simply, we have 10 raised to power minus 3. So 10 raised to power minus 3 square. Because this was 10 raised to power minus 5 now. So we will have 10 raised to power minus 3 into volume. So volume is the length. Length will take 0.5 because it is not contracting. And area is 4 into 10 raised to power minus 6. So we will just have to solve this and we'll get our answer. Okay. So this will be 20 into, this will get cancelled. Okay, so simply we will have 10 raised to power 11 into 10 raised to power minus 6 into 10 raised to power minus 6. So it will be 0.1, right? So this will be our answer, energy. Perfect. Let's move on to our 12th question, last second question of this video. So we have this. Okay. Now, what is given in this question is a composite rod is made by joining copper rod end to end with the second rod of different material but of the same cross section. So this is our one rod and this is our second rod. So this is copper, let's say. At 25 degrees Celsius, the composite rod is 1 meter in length. So this is 100 centimeter, in which copper is 30. So this is suppose copper, this is some metal X, we don't know. This is 30 centimeter, so that this will be 70 centimeter. At 125, the composite rod increases by 1.91. So what will happen? It will increase, right? So this is at 125 degrees Celsius. So if it is 100 centimeter, then this will increase 100.191. Okay, so simply I can write delta L total is 1.91 millimeter. So delta L total will be delta L of copper plus delta L of material X. The composite one is allowed to expand by holding it. Okay, so we will not allow it expand. The two length of two constituents do not change with the rise of temperature. We know find the Young's modulus and coefficient of linear expansion. So we have given alpha of copper as 1.7 into 10 raised to power minus 5, and we have Young's of copper, so it will be 1.3 into 10 raised to. So it's a easy question, right? So we have delta T, so delta T is 100. So from here we can find delta L upon L, which is strain, will be equals to alpha of copper into delta T. So this will simply be 1.7 into 10 raised to power minus 5 into 100. So we will have 1.7 into 10 raised to power minus 3. This is our strain. Okay. So this is strain of copper, right? Okay. Now we know the length of the copper is 30. So we can find delta L upon 30 centimeter equals to 1.7 into 10 to the power minus 3. So delta L will be 1.7 into 30 into 10 to the power minus 3 centimeter. To convert it into millimeter, we'll have to multiply it by 10. So it will be 17 upon 10 into 30 into 110 to the power minus 3 into 10. It will be millimeter, right? So this 10 will get cancelled. We will have 17 into 3. It will be 1 and 5, right? 17 into 3, right? Into 10 raised to power minus 3 millimeter. So delta L of copper we have is 0.51 millimeter. So delta L of X will be 1.91 minus 0.51. So it will be simply 1.4 millimeter, right? So if delta X is we have, so we can find delta L by L of X, which will be 1.4 millimeter divided by, so 10 raised to power minus 1, it is in centimeter now, into 10 raised to power minus 1 centimeter divided by 70 centimeter. So we will have 2 into 10 raised to power minus 3, right? So this is strain of X. Okay, so simply we can find Y as stress upon strain. Okay, let's first find. So you see, we have all the information. We just use the formula. So it will be alpha of X into delta T. So alpha of X delta T is 100. So it will be 2 into 10 raised to the power minus 5. The first information we got. Yes. So it's a linear expansion of the second law. We need to find the Young's modulus of the second law. Now, perfect. So look, if they are between the clamps so that their length, we are suppressing it from change. So stress will be same in both the rods, right? So first we'll find the stress in copper. It will be Y into strain of copper, right? So Young's modulus of copper is given 1.3 into 10 raised to power minus 11. So it is 1.3 into 10 raised to power 11, and the strain of copper was 1.7 into 10 raised to power minus 3. So it is 1.7 into 10 raised to power minus 3, right? So we will have 1. It will be, this is 2.21 into 10 is to power 11 minus 3, 8, right? Newton per meter square. Okay, this is stress of copper, which will be equal to stress of X. So simply we can write now the Young's modulus of X will be stress of X upon strain of X. So stress of X is this 2.21 into 10 is to power 8 divided by strain of X. So strain of X was this 2 into 10 is to power minus 3, right? So if I divide it, it will be approximately 1.1 something, right? 1.1 into 10 is to power 11. So this is our answer. This is our answer. So it's a bit calculation prone question, but it's easy. Now let's move on to our last question. So 13th. So it's a true false. Okay, so we have another question. Oh, so this is simply based on ideal gas equation. So we'll solve this also. Don't worry. Because temperature, so we'll have one more question, of course. So water in a closed tube is heated with one arm vertically placed above the lamp. So this is vertical arm and it is heated. So we are giving it heat like this. So it's like this, right? Now, if we are heating it like this, the particle will go up. Yes, this process is called convection. So if they are going like this, so they will be moving like this, right? So they are moving in clockwise. Water will begin to circulate along the tube in counter. So this is wrong, false. Right, so this is a simple question. Next, 14. A gas thermometer is used as a standard thermometer for temperature. When the gas container of the thermometer is immersed in water at its triple point, the pressure of gas was this. So look, we have thermometer, okay, and it has gas in it. So this is gas. Now the gas will take the whole volume. So volume is actually constant. So we can simply write P is directly proportional to T. When the gas container of same thermometer is immersed in the system, the gas pressure is this. So this is a simple question. So write P1 by P2 equal to T1 by T2. So initially pressure was 3 into 10 is to power 4. So 3 into 10 is to power 4 divided by final pressure 3.5 into 10 is to power 4 is equals to 273.16 divided by T. So we just have to find T. So T will be 273.16 into 3.5 divided by 3 Kelvin, right? So this is a simple question based on ideal gas equation. So maybe this question is here so because the concept of temperature is applying here. So T will be 318.68 Kelvin. So if you want to convert it into degree, so we have to subtract it from 273. So answer will be approximately 4.45.7 degrees Celsius. It's an easy question, right? Mm, can we solve it using? No, we don't have the alpha, right? So we could have solved it using the change in volume. Oh, so no, the expansion is not here happening. Okay, volume is constant. So we have to use this only. Okay, perfect. So total we have discussed 14th question. Yes. So we have discussed 14 questions, right? So this chapter, thermal property, is quite interesting. So we have seen the more of a moderate questions are here. Okay, so they are not that easy, but they are comparatively tough. Okay, we have discussed till now. So let's finish this video. Thank you.